Whenever you classify waves, you can always classify them in two ways. The first one is according to what they need to happen. Go ahead. According to what they need to happen. Be present in the environment for you to see those waves. That's the first. That's the first way to look at them. What do I need to provide for them to actually be created or happen? The second way is, okay, you created them. How do they look like? So now they are present, but how do they look like in front of you? So the second classification is according to how they really look when they happen. First one, what? Electromagnetic wave. Electromagnetic wave. What's the second one? Mechanical waves. Okay. Yeah. Always. What sign you ever take any documentary you ever see? If you read ES for electromagnetic pulse, EM radiation, EM waves, EM anything, electromagnetic. That's it. Say it. Oh no, no. See, grade 11, it falls in the grade. Oh, that's why. But I just want to touch upon this. Okay, that's one feature that they're called what? EM waves. Okay. Feature number two. Okay, so that's the first thing. Electromagnetic waves are any waves that could travel in what? In what? They can travel through what? Anything that travels through vacuum is classified as a what? They are the fastest in the universe. The only examples that exist of what electromagnetic waves, only 7 kinds. And I talked about them before. The weakest is what? Radio waves. What's the next strongest? Nope. Remember, infrared and ultraviolet are surrounding the visible light. So radio waves, what's higher? Slightly. Microwaves. Then we get into what? Infrared. And then we get into what? Red, rho E, rho G. So we get into what? So everyone, if you want to number them, radio waves gets number 1, lowest energy. Radio waves is 1. Microwaves is 2. Infrared is what? 3. Visible light is 4. Now, if you're infrared, what's the other extreme? Below red, above violet. Ultraviolet is 5. What's more harmful? Now we get X-rays is number 6. And the 7th and most harmful one on the list is gamma ray. Gamma radiation. These are the only things we need to know about electromagnetic waves. Okay, what's the other kind? They cannot travel through vacuum. They have various speeds because it depends on what? Density, temperature, pressure, liquid, solid, gas, blah, 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 all of that. But they are not even in the vicinity of what? Of light or electromagnetic, I should say. You see, I'm very careful here. I'm being general. Electromagnetic waves. What are the examples? You know what? Easiest thing ever. You call the example depending on the material it goes through. So what does that mean? If it's gas, you call it what? If it's air or gas, you call it sound wave. If it's in water or liquid, you call it what? If it's in the ground or a solid, you call it what? Shock waves. Geophysicists, people who study geology with physics, they deal with what? With shock waves and matter waves and solid waves all the time. Classification 2, come on. When when we shook back and forth, we call it what? Say this. Okay. I heard more longitudinal. Yes, longitudinal wave. Longitudinal wave. Okay, what's the other one? How many of you have heard this one in a math course? Yeah, when you talk about sine or cosine waves, or when me and Omar shook it up and down, that's called what? Oh, who can say this word? Transverse. So when you shake up and down, you call it what? When you shake back and forth within the body of the actual length or the body of the actual medium, you call it what? Longitudinal. Okay? No, no, don't copy this. I'll post it for you. But I'll show you the animation. Everyone, you see the particles. The thin lines are moving which way? No. The small compressions where the spacing is small, they're moving what? But if you look at it also, the spread out region, and that's called the you saw the piston shaking back and forth. What's the direction of the wave? Also what? Back and forth. When the particle moving other what? All right. What's the other example? How do you need to shake the wave now? Same direction or up and down? So the directions have to be what now? Yes, you shake it up and down, but you send the wave which way? You see? 90 degrees, exactly. Everyone look. Okay. That's literally how waves could travel either in like longitudinally or most of your body is longitudinal because of blood. Does anyone see how the wave moves? You kind of have to focus on, by the way, all the particles are moving just what? Up and down. Not a single particle is moving what? Sideways. But you see how the wave kind of, you see? Like you need to focus on a peak. Once it appears from the left side, and then just what? Literally, ride the what? Ride the wave.